Welcome back, everyone. I'm John Ball, theoretical neuroscientist using the science of cognition to drive AI progress. In today's talk, I will explain a key function of cognitive AI, how human languages are recognized in real time. The model uses natural science, creating hypotheses that explain what we see and then strengthening them over time as the model is forced to explain more and more. Let's start with pattern theory. I spent 20 years developing pattern theory, looking for a model that solves the slow brain capabilities compared with supercomputers whose performance on biological tasks tended to be poor. It's still the same today. Pattern theory is theoretical neuroscience explaining what a brain does, rather than how it does it, like astronomy can explain planetary motion without incorporating Einstein's theories. The main observation is that brains are unlike computers and are poor metaphors for brains. Fundamentally, digital computers represent data with encoding, while the brain starts with sensory recognition. This is vastly different, and one of the reasons AI has been difficult to progress since it starts with animal-like recognition. I'll come back to this in this series. The history of language recognition has failed until I stumbled upon a linguistic theory called role and reference grammar, or RRG, when my sister took me to a coffee shop in Princeton, where I grew up. The missing piece in my work on brain theory, or pattern theory, was how meaning interacts with the context, and RRG, whose primary developer, Robert Van Bellen Jr., who I call Van, has established with his work that started with the analysis of the wide range of diverse languages in the world. Van is a friend and colleague who has taught me immensely about not just linguistics, but the cognitive science more broadly. I rely on many of his insightful tips about previous work in my field. In today's talk, I'm going to cover how language, spoken, written, or other, is recognized in real time. What is language? What is a sentence? And understanding with a dictionary will all be discussed. There's one question or one answer that we're looking for, and that's it's not what we think it is. This is very different. What is language? Language is about communications, and believe it or not, in the linguistic community, there's debate even about that. But I'm working from the principle, the premise, that language is about communication, and that's what we're going to be using as our goal. This here is the representation of language according to role and reference grammar, or RRG. And what we have here is syntactic representation, probably morphosyntactic representation. These are the words that are composed in order to combine with phrases in order to become clauses or sentences. So these are the words and phrases that we speak, and in RRG, a linking algorithm takes those words regardless of the language, and it converts it into a semantic representation, which is then the thing that we can operate with. And that all takes place in terms of discourse pragmatics, which is the context. So when we say something, how do we interpret that based on what's just happened before? And so here's an example of each of those elements. So if we say this is in some language where you would say in sequence see the man, the woman, but it's interpreted as, in the preferred form, the woman saw the man. But here we've got the word see, which is telling us what its arguments are, followed by those arguments. I mean, interestingly, in that language, we can say we can interpret it as the man saw the woman. And with any language that has these types of ambiguities, people obviously can communicate very accurately. And so there will be tricks, usually pragmatic considerations or context that allows that type of communication to take place. That representation is linked to a meaning representation, a semantic representation. And as we have an example here out of my system, you can see here that in the case of the man gave the dealer the car, if that came through the linking algorithm, that would be converted into the man does something, some activity which causes the dealer to have the car, and at the same time, the man to not have the car. And these are very precise representations, because in this case, the dealer didn't have the car, because then instantaneously he does have the car, and the man must have already had the car because now instantaneously he doesn't. That's the point of this transfer. So that's the semantic representation. And over here in the context side, context is extremely powerful and usually neglected, particularly in the computer science implementation of language. So if you were to say Taylor married Ridge, with only a couple of words, you can drastically change the meaning of what the two of you in a conversation with two people would understand. So if you said, no, Brooke did, that would unambiguously mean, no, Brooke married Ridge. Brooke did marry Ridge. And alternatively, you could say, no, Brooke, in which case you'd be saying Taylor married not Ridge, but Brooke. And those types of tricks, which can be extremely fast, can also be extended with examples like this. No, it was Brooke who married Ridge. And these are discourse pragmatics considerations that allow us to be very quick and extremely accurate with conversation. Okay, so what are the building blocks of language? Well, originally, let's just take an English example. We start with words. So for example, in English, we have cat and cats. We've got the types of verb forms. You can run, you ran, you can be running, you can have run. So there's a bunch of variations around the same particular meaning, known as tense and aspect, and voice for that matter. There's literals like the Wizard of Oz, which is a sequence of words in English, which Wizard of Oz, that sequence of words means a book. It can also be interpreted in the way of composition. So here we can see how traditionally we would understand the composition of I saw balloons. So it starts by having some rules where I is a type of noun, saw is a type of verb, and balloons is a type of noun. And then we can have a phrase that allows us to convert that particular noun to a noun phrase. Perhaps we're even incorporating the fact that it's first person, and this is a first person verb. And then we can match a phrase which says that noun phrase plus a verb is now a verb phrase. And then we can continue with that verb phrase plus this noun phrase is now a sentence. And that's giving us the syntax, but it's never been a great system because this system using parts of speech is highly ambiguous. And even in very simple sentences, it's not possible for somebody to determine what it means out of context. And this system was expected to run without any context being included. And so I'd like to think of what I'm now going to show you as the problem of science that Einstein was recognizing. You can't solve problems with the same thinking we used when we created them. I don't think that's quite the real quote, but it's good enough for my purpose here. The point being that we need to think differently to the thing that we're thinking about when we get the problem in the first place. So let's have a look at this again. So what can we do with word composition, for example? So in this case here, we've got some word in some language, and what it means is it to her he gave, and that's a fair bit of composition at the word level. Now in English we do that composition with particular phrases. So in the case of predicate classes, we would be doing that with word sequences in English, but in this case, this type of predicate class in that language allows all of that work to go on at the word level. In the case of the Wizard of Oz, we'll change this composed literal so there would still be that, but there's another type of phrase that we could recognize like black sheep. And in the case of that expression, we can say, well, the black sheep is the bad person in the family. It's the one that stands out from everybody else. It's the black sheep, metaphor being the black sheep standing amongst a lot of white sheep. And so those still exist in the world. And so we're looking at what sort of patterns that we can create in order to generate language. And so we've got things like this, which are collocation of words. We've got things like this, which are composition of words. And then we've got things like this, I saw balloons, which is composition of the meanings of words. It's the generic way that in this model, we understand language. And so in this case, I saw balloons, what we're recognizing, you can imagine it, a phrase where we have a referent here. So it's a thing, a referent, and it's a valid reference phrase. We're going to be talking about these again in a moment. And it's first person. And in English, we want the referent and the predicate, the verb in this case, which is a two-role state. We want it to have tense and be a first person form as well. And so now we can combine I saw in English with something that's valid. And then balloons is also a referent and a valid reference phrase. And we can now manipulate those objects in order to create the overall meaning. So let's have a look at how I saw balloons works in practice with the system that I'm talking about. And if you have a look at my US patent down here, it actually has the details in exquisite detail, in fact. So patent number 11955115, and it's got the world's longest title about semantic-based NLU system, etc. But let's have a look at how it works. So in this case, we've got a meaning-based system. So we're going to convert I into a meaning, and there can be multiples of these. So we've got I would use this nomenclature to be it's a referent, it's a thing, and it's I. This is all language independent, and that's language dependent, obviously. Saw can be a predicate called see, so past tense of see as I saw, and we also have here a referent saw. That's going to be the type that you're going to cut wood with, for example. And then balloons is the referent balloon. Now there's other parts of the word's meaning that we use, but this is the high level concept. And so at the meaning level now, this R:(I) is connected to referent. It's just saying that this is a thing. This P:(C) is a predicate, this R:(saw) is a referent, and this R:(balloon) is also a referent. Okay, so that's just the fact that we're using meaning to compose more information, and over time this would be learned. Now, we also have a concept of phrases, and we can have phrases that are only one word, or we can have phrases that are more than one word. In this case, we're going to have a one-word phrase, and what we're looking for is something that's a proform, a pronoun, and if we have a referent that's a pronoun, what we're going to do is we're going to add an attribute called valid RP. And if we have a referent that's plural, we're also going to add an attribute called valid RP. And as a result of that, we have valid RP, which is added to all of this information that we're tracking in order to recognize this sentence. So we're just packaging together some information. Now, against valid RP, we can also store phrases. And in this case, if we find a phrase, we can have valid RP that's first person and a predicate that's first person. And what we're going to do is we're going to say this is the start of the LSC, the layered structure of the clause, or a sentence, if you prefer. So this phrase, if we match in this case, well, let's see. This is a sequential pattern this time. I know I'm drawing it in a box this way, but we're looking for valid RP first, followed by predicate. So we've got valid RP, that's okay, and it's first person because that's going to be associated with this I referent. And then the next one we see is this one, the predicate, which is also first person. And we've got, let's see, a referent here, which doesn't match because we're looking for a predicate. So we're going to now match our I with P:(C) because of this phrase, and we're going to store it as the start of LSC so that we're now starting to track this sentence. And start LSC can also have phrases associated with it. So if we find start LSC followed by, it's another sequential pattern, valid RP, which we've gotten over here, we then add, it's a two-person argument LSC. And so we've now got that, and then it can also be matching a pattern where, and this is a one element pattern. It's looking for two argument LSC, which is linked to this, and it has a two-role predicate, which we're tracking from here down to there. So we C is a two-role predicate. We'll talk more about that as we go. But this technique allows us, with only a few phrases to match, it allows us to recognize this sentence unambiguously, because the step here, which we'll talk about in a moment, validates that this has meaning in English, because obviously these are English words and these are English phrases. So we see the nice split between things that are linguistic, so the syntactic, the morphosyntax is now linking to meaning, and over here will be the step where we actually get the meaning. What you're also seeing is this concept of it's one of the AI challenges. It's the frame problem of AI, that potentially we have millions and millions of phrases that we care about in multiple languages. But to do it efficiently, we can index these off some pattern of what we're looking for, rather than simply storing in a database and then having to go through everything. That's an example of the difference between computers and brains. Okay, so let's move on. What's a sentence? What does it all mean? That's the point. In a sentence, we're trying to compose meaning so that we can communicate complicated ideas. And if you ever see a Tarzan movie, me see Jane, you have to sort of think about, what's he talking about? Or Jane see me? Are we talking about the same thing? Or Jane see I? So by having very clear sentences, we're able to communicate meaning very accurately. And I like to start the story these days with this concept of transformation. So Zelig Harris, this is 1956. It's an old theory, but what he was saying was that if we think of a sentence, there's two types. There's simple sentences that only have components that connect together, and then there's complex sentences where you take one of those simple sentences, you repackage it, and you stick it inside another sentence. And I like that idea. So if we look at this example here, we've got the man is tall, the party is in an hour, the man will go to the party. This is an annoying way to talk, because we're repeating ourselves. So we're certainly not finding a way to save time. The man is tall, the party's in an hour. That's three simple sentences. But if we repackage them, we then get a complex sentence. The tall man will go to the party starting in an hour. And when you think of it, people speak like the second one, not like the first example of three separate sentences. And it's just more efficient. And you might think, but why would you go to that complexity? Now you've got to unpackage it. It's because the brain does this easily. It's a trivial exercise for brain that also does things like recognize complex visual scenes and auditory analysis. And in role and reference grammar, we have two of the major building blocks being the layered structure of the clause. And here we've got the sentence that is at the very top of that. And reference phrases, which are where nominals or nouns are the basic building blocks. So most of the repackaging of a simple sentence takes advantage of the RP, and by combining then an RP inside an LSE, we're able to understand the whole sentence, which can be conveying an awful lot of information really quickly. Okay, so I like to talk about semiotics because, one of the points was that Van pointed this out to me some time ago about semiotics, and then I discovered Charles Sanders Peirce because I saw a lecture on that, and Peirce had a very novel way of explaining semiotics. So here's a young Charles Sanders Peirce. So you can see that he died in 1914. So his theories were very strong at the end of the 1800s. And he had this concept that the sign, like a word or perhaps even a phrase, that's the representamen that he called it. And then it has a meaning which is interpreted, because you've got the real thing in the world that you're referencing, and this interpretant in context is then determined to be the correct meaning. And the thing I like about this model, rather than other theories of semiotics, is that it allows this interpretation stage to take place. And when you think about a dictionary, there's often more than one definition to consider. And then here in our RRG representation, we've now got predicates and reference. The predicates are not the words themselves, but the word's meaning, which is defining its associations. And its associations include the arguments, the things that it's acting on, and it limits them. And then we've got reference, which have semantic relations. Here's the Harris transformations. So you can start with things like a tree fell, so that's a noun followed by a verb. A rock struck a tree, a noun followed by a verb followed by a noun. And these sequences he was very focused on as being a very critical system for transformation. So we've got a bunch of samples here of sequences, but here below we can see the transformations themselves. So I like this might be the simple sentence, and this I like is the repackaged sentence. A better example is probably this one, books are interesting, and then you repackage it into a reference phrase that can become part of a complex sentence. Interesting books. The bulbs are from Holland. Bulbs from Holland are something. So this concept of transformations is excellent, and I like to rely on it with one limitation. We're missing meaning and context. It's relying on these parts of speech, and these are terribly ambiguous. And if you're trying to work out what a sentence means and you've got 10 ways of interpreting the grammar, and the only thing that you're doing is interpreting grammar, you're stuck. There's no way forward. And the world suffered with this probably for the last 70 years, because the thing I'm showing you now is a solution to this. So let's move on to understanding a sentence. So we start with these predicates, such as destroy being a verb, destruction being a noun, and party also being a predicate. It's an event, but that's also a noun. And then we've got reference or things. Things are much easier to talk about than nouns because nouns are both. So we've got IBM, John, the cat, a spatula, London. These are all noun phrases where spatula, cat, John, that's the nucleus, the main information packaged up in a reference phrase. And I like to say language isn't easy because we can describe everything that we experience. And in the case of this concept of metalinguistics, when I say cats is 4 letters, you probably think, wait a minute, that's not right, because syntactically cats is plural, and therefore we should say cats are 4 letters. But what we're actually saying here is cats, the word. Cats is a word with 4 letters, or the word cat is 4 letters. So as a result of that, we aren't following the simple rules that you would otherwise assume that we're trying to follow if you had the rules-based model, or the very popular model for the last 70 years, the Chomskyan model, or his first one. And then cats are furry is now complying with the agreement rule. Now, if we change building blocks to semantics, what we're doing, so instead of just the building blocks being words, if we now start working at the semantic level, now we've got these things that are reference. So some of these are nouns. There's also some predicates that are also used this way. And then we got predicates where you've got some nouns, you've got verbs, adjectives, adverbs, prepositions, as that said. But now let's apply this theory, this model, to some sentences. So, excuse me, you can see the party is tomorrow. It's a noun phrase, a verb, and an adverb following. Or John is in the garden. This is an adverbial phrase. It's a phrase, it's a prepositional phrase. So noun phrase, verb, adverbial, or you could say prepositional phrase. And then John is happy. That's an adjective. So we've got noun phrase, verb, adjective. So if the syntactic model was useful, we could say anything that fits this model is now valid for English. The reason I design it, if I was designing it, I would design it that way, is because it would avoid a combinatorial explosion of possibilities as we get into longer and longer sentences. But this was the model that was being proposed in the 1950s, and people tried in the 70s and 80s in particular to make that work, and they struggled. Did I say 60s? This is a big problem in the 60s as well. Notice here, we've got noun phrase, verb, adverbial, which is tomorrow. If I substitute in for the noun phrase, the man is tomorrow. What's that mean? I don't know. Should I assume that it has the same meaning as this somehow and try and work it out? I mean, semantics don't allow that to work. Well, not if you're saying the man, but another noun, the party, it's okay. How about this one? John is in the garden. The party is in the garden. Yeah, that sounds okay. So events, the same as people, can be positioned in space. So this one is now valid. How about this one? John is happy. The party is happy. Yeah, I can't imagine what else would be said in order for the party is happy to make sense. It's broken here. So what's really going on is these predicates like happy, in the garden, and tomorrow, they only allow certain arguments to take place. And therefore, if it's the wrong argument, it's not allowed. So predicates determine their arguments, and the other way around, arguments determine their predicates. So the meaning of one word determines the meaning of the other words in the sentence, and the other words in the sentence determine the meaning of that word. So that's how languages work. And there's the reason why the old parts of speech model isn't adequate. Predicates determine arguments and vice versa. So let's have a look at how layers work, because we're not just using a verb in a sentence, we also convey meaning as we saw in those last examples, with different categories of things. So the model that comes from role and reference grammar is there's a core, and you can take whatever that core is and you can position it in space with where concepts, with when concepts and why concepts, or temporal and reason. So when we say she is happy, that's actually a core predicate that belongs in the center here, and happy is okay with she. We don't know what she is, maybe not that happy with it, but she is happy. In the garden, so in is the preposition that has the garden and John as arguments, but in this case, in the garden is a location, so it's where. And he walked the dog yesterday, that's a time, so that's when. And in the case of the party being tomorrow, the party is the only thing in the core. In the case of he walked the dog yesterday, he walked the dog is the core, and yesterday surrounds it as when. And we can also take a core like he gave it to them, and then we can give a reason for it because it was valuable. The reason sits at the outermost extremity, and he gave it to them, again, is in the core. So it's allowing us the capability, without much effort, to include time and space. He gave it to them yesterday in the garden because it was valuable. I don't know why, but that's a valid English sentence and it's got meaning, and you can now start to tell the story by using that. Now, I'm not going to cover these in any detail today, but there's another concept that role and reference grammar noted from the vast amount of research on the topic, but RRG's taken it and then embedded it as part of the overall theory. And you'll see at the very end of this presentation just how complicated it became and how thoroughly analyzed it's been to date. If we say he was eager to please, this is one of the old linguistic issues that people were concerned about in the past. If you're eager to please, what does that mean? Well, it means you're eager, and we take this argument he and we pass it forward to the rest of the sentence. He pleases. Now, if you say he pleases, well, the question is, who does he please? Well, we don't know, but he was eager to please someone, and so our interpretation of this takes the fact that he's eager and also he pleases someone. And then he was easy to please. In this case, easy works differently to eager. In this case, we take the he forward, but now it's this is an undergoer, so somebody pleases he. He was pleased in passive. He was pleased by who? So he pleases who, or he was pleased by who? And this is just coming straight out of these predicates that have a particular function to perform in those sentences. And there's a fair bit of variation there, but it's not nearly as complex as other parts of language. The thing about natural science, and I covered this previously, natural science is about experimentation. And I can propose what these things mean, and then I can test it by asking somebody, does this mean that? So does my knowledge representation mean what this sentence says? So we're able to constantly refine the meaning of sentences by looking at sentences in some context and deciding what it means, and then talking to others and seeing if they agree with that meaning representation. So empirical science is a great way of doing science because we can keep refining at very granular levels. This model, this is what that same patent is proposing. which is that we're effectively labeling pieces based on this layered structure of the clause and how these elements act syntactically. And then we basically fire them at this dartboard and we work out which predicates allow these reference. And so by given a set of things, which I call a consolidation set, we then can try and map it across to semantic meaning to this layered model. And if all of the predicates pass, we've now got a possible interpretation for the whole sentence. And as a result, we're greatly reducing the number of possible interpretations we get for lots and lots of sentences. And finally, we can use context to resolve any ambiguity. And one of the great things about context or discourse pragmatics is if we don't know an answer, we have this incredible trick, which is we can ask the person that said it, do you mean blah? And again, with maybe only one or two words like yes or no, you can determine what the correct meaning was when given a couple of choices. So let's go on to the dictionary. This was discussed greatly again in the past, in the 60s, 70s, and 80s, when the parsing models were at a frenetic level. And most of those parsing models were rules-based. People would write hundreds and then potentially thousands of rules trying to interpret a language based on parts of speech. And just the fact that it's too simple meant that it was never solvable. One of the things I say about it, was talked about at the time, was as you push in a new one of these syntactic rules, a whole bunch of the rules pop out because they no longer work. And so this push in, pop out principle with syntactic only linguistics was a nightmare. And it's requiring additional science to bring in meaning and context, which we always knew was required, but people thought that was going to be hard. So let's just do the easy bit, which is the syntax. No, you have to solve the entire problem to solve the problem. Now, let's just summarize again. So we have predicates and reference. Predicates are things that have arguments. There actually are predicates with no arguments, but depending on the language, the words convey particular types of meaning, which then constrain further what we're talking about. And then there's reference, which can actually carry a massive amount of semantic information because these reference can incorporate a lot of learned knowledge. And if we get the context right, all of these things will automatically learn and take us to the next generations of AI. And then I mentioned metalinguistics is just one of those little annoying things that helps explain why syntax only or syntax first was never successful, because there's too many complexities that you start adding that are solved by things like context. Now here's a detail of a dictionary. This comes from the WordNet website at Princeton. Guess who I was talking to when I was in Princeton back in those years when I found the book on role and reference grammar. But I'm a really big admirer of George Miller, and Miller created WordNet in the 80s and took it forward. I was fortunate enough to have a very short call with him that my sister organized in Princeton at the time, and it was a real thrill to meet him, even in his later years. But what he points out in WordNet is that nouns, for example, because all of his work was based on the current theory, which is still current today. There's nouns, verbs, adjective, adverbs, so there's syntactic elements, and we'll describe language with syntax. But what a dictionary is doing is it's mapping from syntax, or the head words, the nouns, verbs, adjectives, and so forth, it's mapping them onto meaning. But rather than using a meaning representation, it uses words in the language to describe the meaning. And all we're doing in a semiotics model is we're converting that meaning that's described in English for an English dictionary, we're converting that into meaning with all of the elements that we know, and then we use that when we're conversing. So the meaning is incredibly rich, and it allows us to learn what the meaning is and then use it for years. And that's obviously why having a good dictionary is critical. But getting back to it, one of the things that George Miller pointed out in his section on the nouns was that you'll often describe a word. And so here's the complex word, Michael Faraday. So this is my distant relative from England. And what in the definition for Michael Faraday, we get the English physicist and chemist. Now, what does physicist mean? Well, a physicist is a type of person. What's a chemist? A chemist is the type of person. So we're saying that Michael Faraday is a person, and then we provide extra information, physicist and chemist. So he pointed out that that's a very common way of describing a word. And if we look down here, we can see nouns. What's a cat? So this is the house cat or a pussy cat. It's a feline mammal. So we're describing the fact that it is a mammal. So we're giving a category, and this is called taxonomy. So let's say you can have a bozo, the cool cat. It's an informal term for a youth or man. So it's a man. A man's a person. It's a youth person. So we're very quickly identifying the category, and that category is in blue. It's the is-a relation or the hypernym relation. It's the this is a kind of that. Let's see. We've got a cat here. It's the leaves of a shrub. So it's leaves. So wouldn't it be great if we were able to exploit the fact that we know that this is a kind of that, and we can then use that when we're recognizing sentences, and we can. So a cat of nine tails, you can call it a cat. It's a whip. So by going from cat to these different meanings, and then the meanings having different associations with them, I'm going to show you how we exploit that in order to understand the language. And also how to learn the language. Now, so that was the is-a relation. We've also got green has a relation. So we have things and reference, and these things can then have properties. And in this case, a cat of nine tails has 9 knotted chords. So it's the holonym connecting to its component parts or its meronyms. And so that's also some useful information to get when we're talking to someone. We can just use one word and we know what that word has and what that word is, so that we can, what categories it is, in order to understand a lot about it. And finally, we have this red or orange color. It's a predicate. And we can see here that Michael Faraday discovered electromagnetic induction, and he lived at this period. So there's another temporal predicate. So by simply storing these in a semantic network, a non-lossy semantic network, so it's basically a chunk of context in semantic building blocks, we know that he discovered electromagnetic induction. So based on that, we're going to be able to do a lot with nouns. We can build some very useful information. But here with verbs, you can see here their definitions are a little bit different. Destroy means cause the destruction of, undoing of, or it can mean here ruin, damage irreparably, and so forth. So this one's more about if you cause the destruction of something, you're describing its arguments, and the limitations on the arguments of a predicate are critical. So here we see predicates seem relatively simple in terms of their information content. They relate things like time, space, and reason. That's the LSC, layered structure of the clause. And you can get an example like pick up, which means cause to have by lifting. So you're picking it and you're moving it up. Might be a literal way of interpreting it. And there'll be some synonyms and different senses of that word. But that's an example of a predicate. But if we take a referent, now we can actually store complex knowledge in its definition. And it's probably one of the reasons why we don't store, like Napoleon Bonaparte wasn't originally put into a dictionary, because you can have an entire encyclopedic passage about him. But we can actually build up a lot of useful knowledge just in the dictionary, and we could use this format to be storing massive amounts of information. And all of this is in a language independent representation, because these associations, the hypernyms, the meronyms, and these predicate relations are simply sequences of relations that are being constrained by the way you'd write it out. So here we've got IBM is a company. That's a hypernym relation. It had 293,000 employees in 2024. It's a meronym. Has a revenue of 100 billion. Possibly that's a good meronym example. Maybe it's predicate. And then makes a range of computers. That's what they do. That's a predicate association, and works on quantum machines. That's another predicate relation. So you can see if you just said IBM and you said, well, it's a noun, well, so what? But if you say it's a company with a large number of employees and they make computers, you actually understand a lot just by having the meaning of the word. And provided you can identify this in context, if somebody says IBM and they actually mean International Business Machines Corporation, the one that's in the US, or they mean the ticker that's wherever it's listed, whichever stock exchange it's listed, then this is all very valuable. Okay, so let's drill down into a bit more detail. So predicate class, you think of it as a verb, but there's a lot of variation across the world's languages. Across any language, there's a lot of variation because meaning has a lot of variation. So here are the building blocks. State and activity are the building blocks of the semantic representation. A state is something like being happy. So you've got happy here, and then you've got its argument, or it could be know. So in this case, you know something, and then you've got two arguments. So I know something. And so that's a state predicate, and that's how they're drawn as a representation. There's an activity, which is where you do some activity. There's the name of the activity. And again, this can be one role like running. If you run, you're running. Or you can have a second role here, give. So you can, or have. If I have something, then I have the thing that I have. So there's extra arguments. And then there's changes of state, instantaneous changes of state over time. And so these are the different types. And over here in this other table, we can see examples of different predicates. So snow, for example, has no roles. So when we say it is snowing, we're not saying it. We're not pointing at the it thing. No, we're saying it's snowing. And English doesn't allow you to say snowing by itself. So to put it in a sentence, you give it some tense with is, and you've got it is snowing. No arguments. Faint has one. Limp has one. Drink has two. So I drink something. You can leave the other one out, in which case you're drinking, but you're still drinking something. You just aren't specifying what it is. And then there's other examples like you can smash a car with two arguments and show and give with three. And how you build those into the sentence is this concept of valence and macro roles that role and reference grammar uses to model the world's languages. So let's have a look at those different predicate classes in a bit more detail, because we want to be able to generalize. And so if you have the concept of C, the meaning C, and you look at the most commonly used, because C is a very, very common concept that we use in conversation. The 11th most popular word is the word see in English. The 14th is look, like, I'm looking at something. The 37th most used word in English is show, and the 62nd is watch. And watch as in the predicate watch, not the thing on your wrist. So here we're seeing that the concept of see can be reused and provide massive information, massive useful information by just which word you choose. So if we start with the word see, we get this semantic representation, and there's the actual words, but it means see. If you cause somebody to see, you're showing them, and that means somebody does something which causes somebody to see something. And so you can see causality as being explained just from the word, and the sentence that you build for it, because these are different predicate classes, are determined by its meaning. So if something causes something else, like I'll show you the sunset, you've got me doing something which causes you to see the sunset. So very specific, but also you see the sunset. If I show you the sunset, do I see it? Well, that's a question of what the semantic representation is. In this case, I'm saying it just causes you to see something, but that's a way of expanding on its representation. Equally, if you watch something, that's an activity of seeing. And so if I watch the bird, I'm watching the bird. But yeah, it's different how we can use states versus activities. So I can intently watch a bird. I'm not sure I can intently see a bird. I see a bird intently. It doesn't sound like the way I'd use it, because see is just the state of experience, whereas intently doing it is an ongoing action, which is done in an activity. So it's a very powerful concept. And there's a bit more, but we're not going to cover it today. This was the thing that I found just remarkable about role and reference grammar. These are juncture and nexus, so it's how we combine elements, meanings in a language. So if you see John, Beth, and Sue, those three elements are now being used as a single reference phrase, and you can combine them in a whole pile of different ways, and RRG goes through how those phrases are determined and how you then represent the meanings for those different types of phrases. I mean, here, these are the interclausal semantic relationships, which start with very simple actions, going right through to unordered actions. So rubbing your stomach and tapping your head, for example, those are two different actions that you can describe in a sentence, all the way down to I walk the dog, where I'm causing the dog to walk. So it's a very terse combination. These in particular are usually talking about two different sentences that you combine in a particular way, like let's see, speech. I said that you're a moron. If I said that you're a moron, I've got you're a moron is part of the thing that I say, and that's being done indirectly. So there's a lot of very complicated concepts that role and reference grammar has gone into that we can then exploit in AI, in natural language understanding. In tiny large language models, tiny LLMs, where we can simply build this dictionary and then use it to understand the meaning of what people are saying in real time, and therefore do away with the unsustainable AI. So this is the start of sustainable AI. Okay, what's up next? Well, John Searle, that's a picture of him about 20 years ago, I think. To summarize today's talk, a brain learns language because it recognizes the world in a consistent way. It tells the difference between predicates and referents, or associations and things. Our ability to talk in real time is strongly supported by predicates because they can determine the meanings of their arguments regardless of whether a phrase matches in syntax or not. By ignoring phrases that make sense in syntax but not in semantics, we exponentially reduce the work of language understanding because there are fewer possibilities to consider. It's called the frame problem in AI often. Thank you again for joining me today. There are a number of shorter talks to cover next that support some of the historical approaches that have been adopted and, consequently, are holding back AI. Next time, I want to reflect on the work of American philosopher John Searle, who recently passed away at the age of 93. He's the guy that came up with the Chinese room argument about why machines don't understand. I look forward to seeing you again then. Take care.